So the first thing I'm going to do in this video is go over the warm-up. So we've got x squared plus 64 equals 0. First thing we do is subtract 64 from both sides. So we end up with x squared equals negative 64. Hopefully you remember that we take the square root of both sides, and when we take the square root of something, we put plus and minus in front of it. So this means x is equal to plus or minus. Now I'm going to factor that. That's the square root of negative 1 times the square root of 64. This means x is equal to plus or minus 8i, right? Because the square root of negative 1 is I, and the square root of 64 is 8. So over here, when I do this one, so that was the answer D. Okay, and then when we do this one, I'm just going to use the box method. 2 and 3i up here, and 2 and 3i down here. So 2 times 2 is 4, 2 times 3i is 6i, 2 times 3i is 6i again, 3i times 3i is 9i squared. Then at this point, we're just looking for our like terms, which are here. So we're going to do 4 plus 12i plus 9i squared. And hopefully you remember that we changed that I squared to a negative 1, so it's going to make that minus 9. So it's going to be 4 minus 9 plus 12i. So that's minus 5 plus 12i. So that was that. All right, now we're going to go into the review for today. So our review notes today are rationalizing denominators. And the purpose of rationalizing a denominator is because there cannot be a radical in the denominator. So before I jump into this lesson, though, I'm going to give you guys a little bit of review. So when we have the square root of a times the square root of b, that's equal to the square root of a times b. When we have the square root of a over the square root of b, that's equal to the square root of a over b. And when we have the square root of a times the square root of a, that's equal to the square root of a squared. And hopefully you recall that the square root and the square are inverse operations, so they cancel each other out, so the answer here is a. Now we're going to use some of these properties to do these problems, okay? So the other thing I want to remind you guys is any number over itself is 1. And when we multiply 1 times anything, it doesn't change it. So what we're going to do with this next problem is we're going to take and we're going to multiply the square root of 7 over the square root of 7. Keeping in mind that anytime we do anything over itself, it does not change the function. So that's going to give us on top 4 square root of 7, and then on the bottom we've got the square root of 7 times 7, right? So that's going to be 4 square root of 7 over the square root of 49, which we should all know is 7, right? Okay, so that's the answer to that one. Now, with this other one, going to do a similar thing, right? So we're going to multiply this again by the square root of 3 over the square root of 3. And this time we're going to put this over 6 times 3, right? Square root of 3 times 3. So that's the square root of 18 over the square root of 9. Now, I'm going to show you something else in just a minute, okay? So we could actually put these under the radical right now, or we can keep simplifying this. So this is equal to the square root of 9 over the square root of 2 over the square root of 9. This is 3 square root of 2 over 3. Those cancel out, so we're at 2. One of my students also said, couldn't we have started that way? And I said, absolutely. Gave them a piece of candy for that. So if we start here, can't we make this the square root of 6 over 3? Yes. So that's just the square root of what? 2. So there's 2 ways to do that one, okay? All right, so this next one is a little different. So this time we're gonna use the property like we did when we did conjugates, okay? So we're going to use the sum and difference here to eliminate inside-outside terms, okay? So what does that mean? That means I'm going to do the square root of 5 plus the square root of 2 here, and I'm going to do that on top too, the square root of 5 plus the square root of 2 here. So in the numerator, y'all, we're going to multiply 4 times the square root of 5, and then we're also going to distribute that to the square root of 2, so that's going to be 4 square root of 2. Now, when we have a sum and difference in the denominator, y'all, this is like when we did our conjugates, okay? So when we're doing this, we're really going to go square root of 5 times the square root of 5, which is really what? The square root of 5 squared. And then we're going to add to that, and I'm just going to do it exactly the way it is here, the square root of negative 2. I'm sorry, I didn't mean to do that, y'all. I'm going to do minus outside of there. We're going to multiply, yes, the negative square root times square root, positive square root, okay? So y'all see this one's negative and that one's positive. So again, when we do sum and difference, remember that the middle terms cancel out, okay? So this is actually going to end up being 4 square root of 5 plus 4 square root of 2, and then this is actually going to be the square root of 25 minus, because that's a minus times a plus, the square root of 4, right? So again, keep simplifying. 4 square root of 5 plus 4 square root of 2. This is 5 minus 2, so our final answer is going to be 4 square root of 5 plus 4 square root of 2 over 3. Okay? Hopefully you guys all see that. Let me put this somewhere where it's out of the way. Up there. Okay. So now this next one's a little easier, right? Because we're going to just multiply top and bottom by the square root of 2 over the square root of 2, right? The radical. So that's going to be 4 square root of 2. Multiply that plus the square root of 5 times the square root of 2. And again, we could put those under one radical. And then we got the square root of 2 times the square root of 2, which is the square root of 4, right? Okay, so then we got 4 square root of 2 plus the square root of 10, because again, we can put those under the same radical, over 2. All right? Now, we could simplify that 4 square root of 2 over 2 and split them up, but we're not going to do that, okay? All right, so here's our next one. So this time we're going real to real and imaginary to imaginary, right? So we got real to real, so that's 5 equals square root of 6 over x. I'm going to divide both sides by the square root of 6. Recall again that when we're trying to get rid of that radical, we're going to multiply it by the square root of 6 over the square root of 6, okay? So on the top, that gives us 5 square root of 6. Hopefully you can see on the bottom, that's going to give us the square root of 36. So when we simplify it, it's 5 square root of 6 over 6. Okay? Now let's talk imaginary to imaginary. So there's our imaginary part. So we've got 9yi equals negative 3i. Remember, we're trying to get y by itself. So we're going to divide by everything that's not y. And again, the way we can check this is by marking out everything that's not y, and all we're left with over there is y, right? Over here, we can mark out that. Wait a minute, where did I get negative 9? That was wrong, y'all. That was not a negative, so we can't mark out the negative. See, even teachers make mistakes, y'all. So that's going to be equal to, that does cancel out right there, though. So this is negative 1/3, okay? All right, so now what I'd like you guys to do is go ahead and do these u-tries and then come back to me when you're done. All right, so you should have noticed that this was really 2 square root of 2 over the square root of 2, right? Simplify that square root of 4 first. It makes it a lot easier. Then we're just multiplying again by the square root of 2 over the square root of 2. So this is 2 square root of 2 over the square root of 4, right? Which is 2. And then what happens to these 2's right here? Yep, so that was just a square root of 2, okay? Here, we're multiplying both top and bottom by the square root of 11 over the square root of 11. So this is 2 square root of 11 over, and hopefully you can see this by now, because isn't this really the square root of 11 squared? So that's just 11, right, y'all? So this is, again, 2 square root of 11 over 11. Should be able to see a pattern emerging here, y'all. So this next one, multiplying by the square root of 5 over the square root of 5. So this is going to be square root of 3 times 5 minus 1 square root of 5, right, over 5. Because again, that is So this is going to be the square root of 15. That was a multiplication symbol right there, y'all. Maybe I should have put parentheses, but minus the square root of 5 all over 5. All right, our last one. Now this is probably the hardest one, right? So this is 8 over the square root of 7 plus the square root of 10. So we're going to multiply this times the square root of 7 minus the square root of 10. Square root of 7 minus the square root of 10, okay? So 8 times the square root of 7 is 8 square root of 7. And then 8 times minus square root of 10 is minus 8 square root of 10. And remember again, what we're doing here is we're actually doing the square root of 7 squared minus the square root of 10 squared. Remember? Okay? So what is this really going to be? It's going to be 7 minus 10, right? So this is 8 square root of 7 minus 8 square root of 10. 7 minus 10, so that's actually going to be 3, right? So our final answer is going to be 8 square root of 7 minus 8 square root of 10 over negative 3. Got one more. So this is again where we're going to calculate our values of x and y that make the statement true. Real part to real part. So this is the square root of 7 times x equals 4. Going to divide both sides by the square root of 7. And so that gives us x equals 4 square root of 7. Recall again that we can't leave it there, right? So we got to multiply it by the square root of 7 over the square root of 7. This is rationalizing the denominator. So we get 4 square root of 7 over what, y'all? Yes, 7. You should be able to see that by now, okay? And then we're going to do our imaginary to our imaginary. So this can be negative 12i equals negative 2yi. Again, divide by everything that's not y. So this, that, this, that leaves us with a y, right? So then we got our I here and our negatives. So this is equal to what? 12 divided by 2 is 6.